Greetings. My name is John Gabriel, and today I'm going to discuss the topic of how do we measure fast or slow, and several other things. So let's begin. Now, in my previous video, well, I'll get to that in a moment. By the time we arrive at equations such as work is equal to force times distance, which I bungled quite a bit in my previous video on line integrals, several ideas must already be in place, such as time, velocity, acceleration, mass, etc. So before we can even begin to speak about speed or velocity, we must have a well-formed definition of time. So here I give you a link to an article I wrote a long time ago on what is time, and also a fascinating video in this link here on how we realize the concept of time from scratch up till the very completion of the concept. So here are some definitions of the adjective fast, because fast is really an adjective, just as slow is an adjective. So it's moving or capable of moving at high speed, moving or able to move, take effect quickly, taking a comparatively short time. Now, all of those definitions are circular because they depend on time, which already is based on a standard speed. The rotation of the Earth through a distance of approximately 463 meters, or what we call 1 second. We call that distance of 463 meters by 1 second because we compare a distance to get our units of time with the distance of 463 meters approximately. Okay, so all of those definitions that you see over there are circular. Now, fast can take on many different interpretations depending on the type of motion and the elapsed time. So to measure speed in terms of distance, we compare the distance to time, to the elapsed time. Okay, as you see over here, distance covered to the elapsed time. To measure in terms of rotations, rotations completed to elapsed time. So regardless of what type of motion we are talking about, we measure the motion using time. Everything is ratio, and all our measure takes place because of the ratio and what comes from a ratio, which is number. So then let's look at an example. A speed of 60 miles per 10 minutes means each minute measures 6 miles, okay? So that means in order to cover 6 miles, we need to have a time elapsed of 1 minute. So speed is a quotient measure, in other words, division. Force, on the other hand, is a reciprocal quotient measure, which is multiplication. So suppose we have a mass of 2/3 of a kilogram and an acceleration of 6/5 meters per second squared. Then the force is equal to 6/5 divided by 3/2, which is equal to 2/3 divided by 5/6. And using our definition of multiplication, which is defined in terms of division, we arrive at 4/5 kilograms times meters per second squared. Now notice it doesn't matter how you perform these operations, you will get the result that an acceleration of 5 meters per second squared measures each 4 kilograms, or rather 1 meter per second squared measures each 4/5 of a kilogram. All right? Now, Newton's ratios that described his equations of motions are all realized as finite differences expressed as numbers. So, for example, the number difference in magnitude being measured over magnitude used to measure. Okay, so normally the one that appears beneath the vinculum is used to measure the quantity on top. So all of the ratios are based on discrete differences, so that the idea of speed at any given time, which is often incorrectly referred to instantaneous speed, is impossible unless a smooth position function is available, and such speed is interpreted as the slope of a tangent line. So, any talk of fast or slow without time and a solid understanding of time is meaningless. I hope you've enjoyed this short presentation and encourage you to become a subscriber, download my free ebook on the single variable new calculus, and spread the news of this channel so that many others can come to understand mathematics and everything else that we do with mathematics. My name is John Gabriel, and this is a New Calculus channel. Till next time, friends, goodbye.